Greetings to everyone. This is Lwandile here, the leader and the instructor of Maniko School. Today we actually gonna be doing exercise 2.17 from this textbook here. In case you did not know, on this channel we actually following all exercises on this textbook and we solving them in at least one way. Of course, I'm a person, you guys, I will probably make mistakes somewhere, but as we all know, if you are a programmer, then you see learning is an infinite process for you. You will keep learning. You will never stop learning. So I want you guys to know that in case I make any mistakes, it could be a logical error, it could be something else. You gotta feel free to let me know. I am not gonna get offended by that. Instead, I would gain out of it, right? Because that's what we wanna do. That's what we wanna do as programmers. We wanna keep growing. So what is it you want to do today is actually exercise 2.17. This is the exercise right here. I haven't read it yet, but let's see what it says. So it's a science program. It's a wind chill temperature. How cold is it outside? The temperature alone is not enough to provide the answer. Other factors including wind speed, relative humidity, and sunshine play important roles in determining coldness outside. In 2001, the National Weather Service implemented the new wind chill temperature to measure the coldness using temperature and wind speed. So the formula is this thing we're given here, where TA is the outside temperature measured in degrees Fahrenheit, and V is the temperature measured in miles per hour, and TWC is the wind chill temperature. The formula cannot be used for wind speed below 2 mph or 2 mph, or temperatures below minus 58 Fahrenheit, okay, or above 41 degrees. Write a program that prompts the user to enter a temperature between minus 48 and 41 Fahrenheit, okay, and the wind speed greater than or equals to 2, and display the wind temperature. Okay, now you gotta use math.pow to compute that v to the exponent of 0.16. So here is a sample run. So let's jump on to our IDE and see what we can do. Firstly, as always, we've got to create a project. We've got to give it a name that corresponds to the exercise itself. So it has got to be 2.17. And then this is the folder already created. We simply hit the finish button. Okay. With that out of the way, we need to create a class. Simply call it exercise. .17. So we're gonna have 2.17a, right? Because we'll be giving more than one solution. So this is from student A's perspective. Or in case you don't know where did I get this textbook, this is the link to it. I'm gonna put it on top of my main method. So here is it, you can check it out yourself so that you can get your own copy and attempt these problems. I don't want to talk about the importance of doing so. I presume you guys know. You see, programming is like mathematics. You cannot learn much out of it by staring at it. What you want to do is to go through the experience of doing things incorrectly and then get corrected from there. You don't want to just read them through. If you do so, I'm letting you know right now you're actually wasting your time. So let's get on to our solution now. Firstly, what you want to do is to prompt a user to enter the temperature in Fahrenheit. In Fahrenheit between 58 and 41. You gotta keep our temperature variable, of course, by going temp in far scanner. I want this whole idea of having good variables to sink in your head, even though I know some people might think my solutions are kind of repetitive, but I really don't think so. Oh, we haven't yet created our scanner. Okay, of course we gotta go system.in, and then once we're done with our scanner, we've got to close it. That way our compiler will automatically do the inputting for us. Okay, that's our first variable to hold our temperature. So now let's prompt the user to enter. Hey, again, you guys, I'm really sorry. These students outside Howard College in UKZN in South Africa, they actually making noise now. And I don't know why, because it's actually Sunday. You see, some people, they usually come by, even little kids. I mean, different families, they come by to pray on these classes here on campus. So no wonder we're having a little bit of a noise. Okay, so I'm gonna ask you to bear with me there, because it has been a long walk from home to this campus here, so it's not like I can leave everything because of them. So enter the wind speed, but I promise this is gonna be the last video though. Speed which is greater than or equals to 2. In miles per hour. I don't know if you can hear those kids yelling. I don't even know what is that all about. But what I do know is that I do need to give you. But what I do know is I do need to give you guys this solution. Speed in mph is simply this. On these situations, undo. On these situations, of course, you can copy and paste because it's not something logical. You're not going to be doing any modification afterwards, after you've copied and pasted your whatever is it you'll be copying and pasting. Okay, so we're going to have different terms. So firstly, we're going to have first term will simply be a double, call it variable 1, which will simply store 3.35.74 basically. So we basically breaking down this formula here. That's what we are doing. So we do have our first term, so our second term is simply 0.6215 multiplied by temp infa. Alright, so where is our third term? Third term, we'll call it variable 3. It will simply be 35.75 multiplied by math.pow speed in mph, and then we'll simply put this number here 0.16 as an exponent. Of course, I don't have to explain how does this math.pow method work, because I presume by now you do know how it works. Fourth term now. We are actually on our fourth term. This is our first term, second term, third term, and this is our last term, which is actually our fourth term. Okay, double variable 4 is giving us 0.427 multiplied by our temperature in Fahrenheit. Temp in Fa. How many times do we even have here? We've got 4 times. However, we can split some of them. Alright, we've got 4 times, 1, 2, 3, and 4. However, the last one will simply okay, we can combine it. can go multiply. Let's just put everything in brackets and simply go math.pow we'll simply put speed in mph, and then we put this number here, 0.16. Once we do that, our W will simply be, by W I mean wind, what we actually look for is wind speed. So our wind speed will simply be variable 1 plus variable 2. In fact, this is what we have. It's plus variable 2 minus variable 3. Okay, it's variable 1 plus variable 2 minus variable 3 plus variable 4. Then we're done. Now it's time we display system.out.print. System.out.print the wind chill index is the wind chill index is just go 2.5 F, and I put my W. Now let's see, let's simply, so we were decided to put 5.3 and 6. Of course, we're using printf, not print. 5.3 and 6. Let's put 5.3. We get the exact answer we expected. Oh, by the way, I mistakenly put 14 instead of 4, but that doesn't affect our results. Our solution is still okay. I mean, of course, there's something not right about this solution, and I would really love to hear that from you down below in the comments. So that's pretty much it for this tutorial, you guys. See you on the next one when you actually do this same example differently. That's pretty much it. As I just said, cheers, you guys. See you on the next tutorial.